In lecture 23, we'll be discussing the practice problems related to the if-else statement and the conditional operator and the switch statement. So coming to the first problem, here we need to write a program that prints a response only if n is divisible by denominator, the d. So we take the input from the user and we just write enter two positive numbers, and we take the input using the cin statement. First input is assigned to n and the second input is assigned to d, and then we say that if n is divisible by d, that means if the remainder should be 0. So we are just comparing whether this results is equal to 0. So if this whole expression is true, so we have 1 returned over here. So if this expression is true, so we will be seeing true in the round parentheses of the if statement, or 1 in these round parentheses. And if this thing is true, then cout is going to run that n is divisible by d over here. If this condition is false, then we are not going to see any statement. So we can just write else n is not divisible by d in the next line. Okay, so coming to the next problem. So we need to write a program which prints a minimum of 4 input integers. So we take the input, we just declare 4 variables, integer n1, n2, n3, and 4, and we just write enter 4 integers, and we take the input, and the first input assigned to n1, and all the subsequent inputs are assigned to the respective variables. And then we just assume that the minimum variable, or we just write a name integer min equals to n1. So we just say that minimum is n1. We're just assuming that. So let's say if we then we compare n2 with minimum. Minimum contains n1. So if n2 is less than minimum, then minimum is updated to n2. So we assign a new value of n2 to minimum. If this condition is false, then the minimum would still contain the original n1 or here. Then we compare n3 with minimum. Let's assume that minimum was updated to n2. So if this condition is true, that means if n3 is less than minimum, so it will return 1 or true, then this statement will run. Otherwise, if this condition is false, then this statement will not run. And then we again compare n4 with minimum. So if we say that minimum has now the minimum of these 3 values or whatever that might be, and then we compare n4 with minimum, which might be containing the most recently updated minimum value. So if this condition is true, so minimum is updated to n4. Otherwise, minimum would retain, or minimum would contain the original minimum value, whatever that might be. And we just, at the end of this statement, we just write their minimum is whatever the minimum value is. So just keep in mind that this if statement ends at the very first semicolon. So we do not need to write the curly parentheses or curly brackets because we are not writing a compound statement which is more than one statement if the if statement is true. Another thing we can do is, because this thing is write a program which prints a minimum of 4 input integers. So what if we have if you had like 5 integers or 10 integers? Another thing we can do is, which we will be doing after midterm, is that we whatever the input of the user is, we are going to store in some kind of a data structure which we will call array. So we have, let's say we have 1 2 3 4 5 6 numbers, and we just say that this array, array, we just name this array as something like a, and it will contain the first number a indexed by a0, and indexed by a1, and indexed by a2, and this thing is indexed by a3, and this location is indexed by a4, and this location is indexed by a5. We keep in mind that the index number starts at 0 for any array in C++, and we have to use the square brackets to refer to the correct location within that array. Array is just a data structure which stores the variables of the same kind. We will be doing these arrays extensively after we have done the topic of loops, which are for loop and while loop and do while loop after the midterm. Here what we can do is, let's say whatever the user has input the value. Let's say the user has input the value 77, 44, 33, 99, and 102. So what we can do is, we can call a function which is a sort function. There are many ways to sort different values. We have most basic is the bubble sort, and then we have the insertion sort, and we have the other sorting functions as well, many of them actually. So we have quick sort as well as the merge sort and so on and so forth. Many sorting methods available, which you will be seeing in your next course of data structures and algorithms. And let's say we just call some kind of a sort function, and we pass this whole array to this sort function. So what this sort function would do is going to sort this array, is going to in the ascending order, descending order, whatever that might be. So it will have the 2, then it will have 33 and 44 and 77 and 99 and 100. So if we have a sorted array after calling the sorted function, if we have the sorted array, so we can pick the very first value, which was a0, and that would be the minimum value, and we could have also picked the last value, which was a5. Remember, the index goes from 0 to 5, or total elements were 6, so the index value will go from 0 to 5. So we could have picked the very last value of the array, and that would have been the maximum value in this array. So it depends on how many integers you want to take from the user. Let's say you want to take about 100 inputs from the user, so you have to declare the array of size 100, and the index value will go from 0 to 99. If you do not know the size of the array, you can use something known as a vector. Vector is essentially a data structure. Essentially, behind the scene is a resizable array, which C++ handles itself. You do not need to you can declare the size of this vector actually, but if it's not declared, then it's actually kind of a resizable array. Whatever the inputs are coming in from the user, the array is resized appropriately depending on the quantity of the inputs from the user. So this is one way to do it. If you have many numbers, so you just sort this array and pick up the minimum value, which is the minimum of all of those numbers, or pick up the first value in this array, which would have been the minimum number had the array been sorted. So you need to have some understanding of how this sort functionality works. We will be doing bubble sort and probably insertion sort or maybe merge sort in this course, because this is actually a topic of DSA, data structures and algorithms, which is the next course which builds upon whatever we have learned in this course. So coming back to Dev C++, so we are just assuming the whatever the input is as a minimum value, and we are just comparing all of those inputs with the minimum value, whatever that might be, and updating the minimum variable as needs arises. So coming to write a program which prints the median of 3 input integers. By median, we mean that let's say coming back to the original example, let's say if we have 3 numbers. I'm not going to write into an array. Let's say we have 3 numbers like 44, 22 and 66. So if we just arrange it in like in the ascending order, 22, 44 and 66, this number is the median. So that means that we must have the odd quantity of inputs. We could have 3 inputs or 5 inputs or 7 inputs, so that the minimum the median value is the middle value if we arrange the numbers in the ascending order or maybe descending order. It's the medium the middle value in that order, whatever that might be. So here is one logic. It's your reading assignment of how, or you might want to understand how this logic actually works. This thing is just comparing that, and it's kind of a convoluted logic, so I would suggest the easier way to do it is I'm just writing enter 3 integers, and I'm taking the input from the user and assigning it to A, B and C in the respective order, and then I'm printing their median is, and I'm not printing what the median is. So if this statement is true, the median would be A. If this statement is true, the median would be B, and if this statement is true, then the median would be C. Now if we have, let's zoom in a little bit. So if we have this scenario, so let's pick a number, or let's redraw this thing in this program. So let's say if we have 3 numbers A, B and C, and A is the median. So we have 2 scenarios. Well, either A is less than C or equal to C, or actually less than C, I'm just assuming unique numbers, and it's greater than B. That's one scenario. Or we could have just swap the values here and here. So there is another possibility that A is less than B but it's greater than C. In both of these cases, A would be the median. So I have written this condition that if A is greater than B and at the same time A is less than C, or A is greater than C and at the same time A is less than B. So I've written this condition over here. So I'm just going to say that if A is less than B, and A is greater than C. So if this condition is true, so I mean the order of the serial numbers would be B, A, C. If B is the largest number, A is the middle number, and C is the smallest number. Or this is the OR sign over here. This is the OR sign. Or it could be possible that A is less than C, and at the same time A is greater than B, which is saying that if we write from the smallest to the from the largest to the smallest, C, A, B would be the sequence of the numbers, and A would be the median of these three numbers. So in that case, if this condition is true, or if this condition is true, then the output would be A. So I'm going to say their median is A. Another scenario is whether if B is median. So we once again we have two scenarios, whether B is in the middle. So I'm just going to write let's write B somewhere. If B is in the middle, so that means B is the median. So either it could be A is the largest and C the smallest, or B is in the middle, C is the largest and A is smallest. So in both of these cases, I need to write B in the middle and compare them with A or C, and I have to keep in mind all the possibilities over here. So if B is less than A but is greater than C, so but or and means same thing, and or it is possible that B is less than C and greater than A, so that means B is in the middle. So we're going to write that the median is B. So if this condition was false, so this thing is not going to run, because if a statement and the very first semicolon, if this condition is true, then this statement will run. The last scenario is there's this repetition of the previous two scenarios, that what if the C variable is in the middle. So if I write, actually it's actually much more simple to write, instead of writing n1, n2 and n3, it's just taking ABC is, I find it much simple to write, just to avoid the confusion of 1, 2 and 3 variable names. So which one is larger and which one is smaller. Either you could have done it with n1, n2 and n3, no problem with that. So if I just take this scenario, that C is in the middle. So if C is in the middle, so that means that C is, A is the largest, C is smaller than that, but it's larger than B, or C is in the middle, B is the largest, and A is the smallest of all three. But in both of these cases, that C would have been the median of these three numbers. So we could just write if A is greater than C, and at the same time C is greater than B, or this could have been true. So if this is true or this is true, if any one of those things, obviously any one of these two statements is going to be true in both of these cases, that C is less than B, and at the same time C is greater than A, C is in the middle, so B is the largest and A is the smallest. So if this condition is true or this condition is true, the whole statement is going to be, the return value would be true or 1, and then we are going to say that their median is C. So if this condition is true, it's going to run, or this condition is true, it's going to run. And if this condition is true or this condition is true, any one of these has to be true for this statement to run, or any one of these statement has to be true for this statement to run. So coming to the next program, modify this program so that it has the same effect without using the statement block. This is actually discussed in the some previous lecture. Not so sure about 19, 20, 21. Not so sure. You have to take a look in those lectures. In that lecture, what I have written over there is that I have written the function, or not, actually not exactly a function. I've written a code to swap the values of x and y, and then we are going to say that x is less than y. So it was if x was greater than y, this whole statement block was actually running. It was just assigning the value of x to a temporary variable which only existed within this code block, from this curly bracket to this curly bracket, and then we were assigning the value of y to x, and then we were assigning the whatever the value of x was, into which was stored in temporary variable, just a name temp, and it was being assigned to y variable, and we were just assigning the values of x and y, and we are just saying that x is less than or equal to y, and that's it. So but we do not need to swap the values of x and y here. We're just saying that enter two numbers. We're just taking the input from the user x and assigning it to x and y subsequently, and we're saying that if x is greater than y, we're going to say that y is less than or equal to x, or x is greater than y. Just write it over there, or you can just write else see out x is less than or equal to y. If this condition is false, so obviously this condition has to be true. I have not I have actually written this equal to sign, and I should not have written this sign over here. So this is because in that scenario, if x is greater than y, so this statement would have been true if the return value of the whatever boolean expression, we have a boolean expression here, right? We are just actually, it's a comparison expression. We are just comparing the value of x and y. If x is actually greater than y, we are going to see 1 or true return in this round bracket, and then we would have printed y is less than x, or x is greater than y, whatever you want to write. Had x, in two scenarios, this condition would have been false. One scenario is if x is equal to y, because we haven't limited or we haven't restricted a user to write two unique numbers. We are just assuming he or she writes two unique numbers, but if the user types in two same numbers like 22 and 22, so this condition is obviously false, but x is equal to y and x is less than y, x is equals to y, so we are going to say that x could be less than or equal to y, and this condition is false. If you want to modify this program, saying that if x equals to y, keep in mind I should not have written this thing. This is completely wrong. I'm just comparing whether x is equals to y, and I'm going to say c out, and we're going to say that x is some space is equal to, and then we're going to say y, and I mean, if this statement is false, obviously this thing is not going to run. If this condition is true, then this is going to run. Else, obviously, if this thing is also false, and that means that x is less than y, if you want to write it over there. One more thing actually I forgot to mention was that if you are finding the median of three numbers, so that's one way to do it. What if you are required to find the median of 5 numbers or maybe 7 integers? So these if statements would have the boolean expressions or the complex or compound boolean expressions really wrong and unwieldy. So what we can do is that which we will be learning later on, that instead of taking the numbers and storing them in variables, we will going to store them into arrays. And in arrays, make sure the array size is in odd number. So let's say we have a 7 element array, so 1 2 3 4 5 6 and one more. So the 0 to 6, the index number would go from 0 to 6. So if we sort the array using calling some kind of a sorting function such as bubble sort or insertion sort or merge sort, maybe quick sort, so if the array is sorted, so what we can do is we can pick the middle of the number, which is 0 plus 6. 0 plus 6 divided by 2 would be 3. So we will be picking the index number 3 in this array, which would have been the fourth number in this array. So because the index numbers start from 0 and it goes from all the way to 6, so the middle number, the median number would have been index number 3 or the fourth value. So in C, the counting starts from 0 for array index or indices. But if you're using a software such as MATLAB, the index number starts at 1. So don't mix it up. It depends on language to language or the software package to software package. In C++ or in C language, the index values start at 0. In MATLAB, the index values start at 1. So that's one way to do it. So if you have like a 99 element array, so the index number would go from 0 to 98, and we would have picked up the value of 49 index number, which would have been the median number. But first we need to sort the array so that we have the array in ascending or descending order, and we would have picked the middle index in the whole array for the median value. Coming back to this thing, we are just, you don't need to swap the values, we can just write the statements, so it's really simple. And this is one kind of a question which could be in your exam. So in some previous lecture I've discussed that you could have four kind of questions. You could be asked to write a code for some problem. You could be asked to write a statement for some problem which solves some problem, or you could be asked to figure out what could have been the error, or you could have been asked to write the output of the program without actually running the program. So this is kind of a theoretical question, even though I've copied the code over here and to figure out what would the output be. But if you can remember, this is from the previous lecture in which we discussed the scope of the variable and where each variable is actually visible. So here let's try to predict what would have been the output of this program. So we are going to look at what the cout is. So if I can write over here, or I'm going to write in this notepad. So let's try doing that. So the first thing is integer n equals to 44 in this main function. So we have not written the include iostring using namespace standard. It's understood to be there. Even if it's not written, you could just assume it to be there because everyone writes it, and we do not need to write it again and again. Even if it's not in the exam, you just assume that it's there. Okay, otherwise if we do not write the using namespace standard, then we have to write is std : cout and std : cn with every cout and cn statement. So coming back to this integer n equals to 44, then we say cout n equals to, obviously there is only one variable, n equals to 44 declared, so the output should be, I'm going to write over here, it says n equals to 44, and it will say due to and the cursor would be in the next line, and then it will say enter an integer. So obviously going to write enter an integer, and then we take the input and we say cout n, and this value of n is actually updated because there is no new integer n is declared. So this n actually refers to this n. So the previous value was 44, and whatever the user has typed here, so that, let's say user has typed the value, for example 66, so and the value of n would have been updated, and this would not, this would be visible on the screen after pressing the enter key. We have another statement n equals to 66, which refers to this cout statement, and then we have another block of code, but since no n is declared, so this n is going to refer to whatever the previous n which was visible here. So we have another line again. Let's write that n equals to 66, which is this line here, and then we in this code block we declare another variable n, but this thing is actually hiding whatever the variable which was visible in this space. So this n is visible here, and it will be visible from this point onward to end of this code block. So we just say we have declared a variable, but we haven't initialized the variable. So it will be this cout is going to print some garbage value. Not so sure what that value is. It depends on what computer we are using and what memory space is allocated, and we're going to write some garbage value, obviously some number, whatever. And then in this last line we are going to say cout n equals to this thing. So this n is no longer existing after this point. So this cout n equals to this, so this n would be referring to whatever n was visible here, which was this or which was this. So the last value which was updated value of n was 66. So we have another n equals to 66 here, and I think that's the end of the code. So yeah, so enter an integer, and I'm going to do just run this code. So this whole question is actually a remark, so I'm going to try running this thing. So n equals to 44, enter a number. So I just write 66. So it says 66. Let's compare what we have done there. So n equals to 44, the first line it says enter integer, we just write 66, obviously in the same line, and then it says n equals 66, and then it says n equals 66, and then n equals to 0, some garbage value, could have been any number, and then again n equals 66, which was the predicted output. In the exam or in your test, you might be asked to write the output of some code without running the code actually. Another thing is, that if you compare it with the previous lecture, in that lecture we have declared a variable integer n. We declared the variable integer n here, and then this n only exists from this point on here to this point, because this n actually hides this n. I mean, if we did not declare the variable, which we didn't in this case, so this n is visible from this point onwards to all the subcode blocks, in the case that no further variable of the same name is defined within a code block. So going to the next problem, write and run a program that reads the user's age and then prints you are a child. If the age is less than 18, then it prints you are an adult if age is less than write and run a program that reads the user's age and then prints you are a child if the age is less than 18. You are an adult if age is less than 65. So if age is less than 65, and you are senior citizen if age is greater than 65. Sorry for the bad statement. So it's simple. So we just take the input, we just declare a variable age, we just say enter your age, and we take the input and assign it to the variable age. If age is less than 18, we say you are a child. Else, because this if and this else is coupled with this last if, so if this thing is not true, we're going to check this thing. So it's kind of a parallel scenarios, and we just say okay, if this thing is not true, going to this else, and we're going to check. Look, if age is less than 65, so I mean this thing was not true, so that means age was definitely more than 18. So or it could have been equal to 18. In both of these cases, this condition would have been false. Okay, so this age number has to be less than 18. This is carefully. This age, whatever the user has typed, whatever that number might be, let's say he might have typed 16. So this 16 is less than 18, that would have been true, and then it would have printed you are a child. If the user has typed 18, so 18 less than 18 is actually false. So this condition would have returned false or 0. Then it would have gone to this else statement, and it's going to check, okay, now check whether it's less than 65. If it's less than 65, not equal to 65, if it's less than 65, it's going to say you are an adult. Or if this condition is true, if this condition is actually false, it's going to go to this else, you are a senior citizen. So if the user has typed the number 65, what would have been happening is that 65 is less than 18, that's wrong. It's going to check this thing. 65 less than 65, that is also not true, false. Then it would have run this else, because this else is coupled with this if statement.